Good day everybody, we've been given this challenging question. So let me write the question down. Let P be equal to a matrix 1 0 0 4 1 0 16 4 1 and I be the identity matrix. And if Q being equal to Ij, so this is given in matrix representation, is a matrix such that P raised to the power of 50 negative Q is equal to I, then we will have to find Q31 positive Q32 over Q21. It's a very popular question. So foremost, we will have to evaluate P raised to the power of 50. Now we have been given P. So first, write down the value of P. P is 1 0 0 4 1 0 16 4 1. This is the value of P. Now I have to use one more paper to explain. Next, I want to get the value of P squared. Okay, so P squared is equal to 1 0 0 4 1 0 16 4 1 multiplied with 1 0 0 4 1 0 16 4 1. Okay, so I'll come back to that side again. So row goes with the column. So it's going to be 1 into 1 positive 0 positive 0. Row with the column is going to be 4 positive 4 positive 0. Row with the column 16 positive 16 positive 16. Row with the column, this column 0 positive 0 positive 0. Row with the column 0 positive 1 positive 0. Row with the column 0 positive 4 positive 4. Row with this column 0 positive 0 positive 0. Row with the column 0 positive 0 positive 0. Row with the column 0 positive 0 positive 1. So this is equal to 1 0 0 8 1 0 48 8 and 1. Now we need to find P cubed. So there's going to be P squared multiplied with P, which is going to be 1 0 0 8 1 0 48 8 and 1. This is multiplied with 1 0 0 4 1 0 16 4 and 1. So I take the row, I multiply with the column. So it's going to be 1 into 1 added with 0 added with 0, 8 into 1 added with 4 added with 0, then 48 positive 32 positive 16, right? This entire row is multiplied with this column 48 32 and 16. So it's a huge number. And now the row with the column is going to be 0 0 0. Row with the column 0 plus 1 plus 0. Row with the column 0 8 and 4. First row with this column. So this is going to be 0 0 0 and then a 0 and then a 0 and then a 0. Row with the column, you get 0 0 and 1. Okay, so that is how you multiply, right, in matrix multiplication. So this is going to give me 1 added with all this 1. This is 12, this is 48 and 32. What is that? 8 and 2 is 10, you carry 1, 7, 8 and then you have 16. So this is going to give me 96. Okay, So this is 0 here, 1 here, 12, 0, 0 and 1. Okay, we need to find p raised to the power of n. Now I started off with this paper. If you remember, we started off with this paper. So let me write what is p squared here. So p squared is 100,810 and 48, 8 and 1. So this is my p squared. Now I need to write my p cubed. So p cubed is 1, 12, 96, 0, 1, 12, 0, 0, 1. Okay. Now you have to observe this p squared and p cubed and create the pattern for p raised to the power of n. So that is the all important step we need to do. Now clearly 1 appears everywhere. You see this 1 is appearing all through. So just you retain 1. The zeros appear all through. So it will be 0, 0. Now the diagonal element is always 1. Okay, in all these matrices the diagonal is always 1. You have a 0 there. So we have to get this or these three elements. Element over here, element over here, element over here, nth term. Now these two elements, you see this, you have a 4 here, you have a 8 here, and you have a 12 here. So 4 times 2 is 8 and 4 times 3 is 12. So that means this has to be a multiple of 4. So 4 times n and 4 times n. Fair enough. Now when I substitute the value of n, I need to get 16 and 48. Okay, so the idea is this is 8 times 2, this is 8 times 6, and this is 8 times 12. Okay, 8 times 2, 8 times 6, and 8 times 12. So this is going to be n squared positive n. For n is equal to 1, I get a 2, so that means 16. For n is equal to 3, 3 squared is 9, and added with 3 it's going to be 12, so 8 times 12 is going to give me 96. So this is going to be our required pattern. Now having got this, we need to go back and get the value for n is equal to 50. So this is what is given here, n is equal to 50, right? We need to get that value. So what is p of 50? P of 50 is equal to 1, 4 times of 5, 0, 0, 1, 0, and 8 times of 50 squared, positive 50. This is 4 times of 50, and this is 1. So 0, 0, 2, 5, right, and added with 5, this is going to be 2, 5, 5, 0 multiplied with 8. That is going to be the quantity. And 8 5s are 44, 8 5s are 44, 8 2 are 16, 17, 18, 19, 20. So this is the number we are getting. So P of 50 is equal to 1. This is going to be 200. This is 200. Over here it's 2, 0, 400. Over here it's 1, 0, 0, 0 and 1. Okay. So what we have to do is we will have to take this over here. So let me go to the next okay, so Q is actually Q of IEJ. Okay, so that means Q is equal to Q11, Q12, Q13, Q21, Q22, Q23, Q31, Q32 and Q33. Okay, so therefore P of 50 minus Q is equal to I. So P of 5 0 matrix is 1 200 2 0 400 is going to be 1 and 200 0 1 0 0, followed by Q11 Q12 Q13 Q21 Q22 Q23 Q31 Q32 Q33 is equal to I is identity matrix. So 1 0 0 0 1 0 0 0 1. Okay. So now they want us to find the Q31, which Q31 is needed. So where do we get Q31? Q31 is over here. So 20400 minus Q31 is equal to 0. So therefore Q31 is equal to 20400. Okay, that's the first part. Next they want us to find Q32. Now Q32 is over here. So it's going to be 200 minus Q32 is equal to 0. So Q32 is equal to 200. Next we have to find Q21. So 200, this is Q21, 200 negative 21 is equal to 0. Therefore Q21 is equal to 200. So now we have to find Q31 plus Q32 divided by Q21. Now my Q31 is 20400, positive Q32 excuse me, that's 200, Q21 is 200. So this is equal to, you add up these two things, you get 20600 divided by 200. 0 gets cancelled. So you have 206 divided by 2. 2 divides 200 or 2 once, 03. So therefore this is equal to 103. So that's a solution for this question. Thank you everybody. Please like, share and subscribe.